Awesome. Okay, cool. Great to see you guys again. It's a beautiful day, and I'm excited to teach you guys a little bit about the graph today. We're gonna focus on like what the graph is, like why it even exists, and why it's kind of very critical part of like building decentralized applications. And then we're going to try to like set it up really quick too. So I'll probably do like 15, 20 minutes of slides. This will be like the only talk that I'm giving. I usually do everything like demo, but I think it makes sense to like set the tone and explain to you guys um, about how it works a little bit and like what problem it solves first. And then we'll actually set it up using a special extension for scaffold. It's called the subgraph. Okay. So let's get going here. Alrighty, so start out. Let me just go ahead and share my screen here. Cool. Can you guys see that okay?
Perfect, yes.
Cool. Okay. You guys already know who I am. So we're going to talk about what the graph is and why it's important. And then we're going to take a look at some of the configuration and the architecture of it. And then we're going to do like a small demo. Okay. Um, so the first question is, if we just think about very, very basically, like, why do we need to index data at all? So this could be for like Web 2 stuff, or it could be for Web 3 stuff. Uh, the primary reason that you need to index data is because you need it in a way that is easy to consume and makes sense based on your application. So in other words, like if you're going to create a database that keeps track of all of your users, you're going to probably create tables that relate to how you're storing information about those users, right? Similar to a smart contract, you write a smart contract that stores variables, and you probably want to index data that comes off of those smart contracts as they change into a special format that makes sense for your application. Uh, Also, if we look about the blockchain and the way it works, is it's transaction based. So you sign transactions and you submit those transactions to the network. Your smart contract emits events, right? So if you're a good smart contract developer, you are probably writing an event for every single thing that happens in your smart contract so that you can keep track of that stuff that changes and make changes in your UI or be able to index that data. And so this data that come off the events is usually very like critical to the operation of your application. And so what we actually want to do is do something like if we look at like a simple NFT example, this is kind of like what the data storage of an NFT looks like. It's basically got an ID, which is the token ID, like the actual instance of the token, its current owner, which is the address that owns that NFT or has minted it or transferred it, and then the off-chain data, which is stored in this like metadata URI. So as people make transactions to create NFTs or transfer NFTs, those events get emitted with the data that's available inside of the NFT, right? And so what we want to do is be able to solve some problems with this current architecture. The current architecture is all of this transaction and event-based kind of system where there's transactions happening and then there's events happening. And then that is basically updating a, database inside of the smart contract. But when it comes to like reading the data from the blockchain, there's a lot going on. So on any given like block on Ethereum, there are thousands and thousands of transactions. And it's very hard to distinguish like where those transactions are coming from, who are they going to, what happened in the duration of that block. And then on top of that, some blockchains you have a new block every 2 seconds. Sometimes you have a new block every 10 seconds. And so it's constantly changing, right? So you can see how this gets very confusing, especially if you're like a developer and you want to search for something in a given block. It can be very difficult to figure out when that happened. Going back in time is pretty much almost impossible unless you know the block number. So it's just a little bit complicated in that sense. We also think about the first architecture of a dApp, which is kind of becoming obsolete now, is that you have a user interface, like in our case, Scaffold ETH is React with Next.js, and then you have the smart contract deployed on the blockchain. But your application usually writes to the blockchain for the security of the blockchain. And then when you read from the blockchain, there is no incentivization for the data to be quick, responsive, and then easy to consume. So the blockchains are not really designed for reading data. They were really designed for the write mechanism, which is, the security of writing to the blockchain. And when you start to want to read lots of information, it can be very complicated because, well, first of all, you need to know exactly what you're looking for, and then you might have to make multiple calls and loop over to get the data that you need from the blockchain. We also have a problem with provenance. So if we think about like the history I talked about earlier, there's so many blocks that happen and that's what a blockchain is block after block after block. And so going back in time to see what happened, there's no really easy way to do that. Like you can't query the blockchain and say, hey, give me all of the owners for this particular NFT. And, also tell me at the time, like, I don't know how many NFTs were in existence. So you don't have that ability with the current implementation of like the RPC. So what we want to do is something like this, where we are keeping track of everything that happens. I don't know if any of you guys remember Time Machine, but it allowed you to go back in time and see what had changed in a file and get access to that. It's a similar method with the graph, is we want to keep track of all that data, but we also want to be able to go back in time. And so this is an example of an actual developer that was trying to query directly to the blockchain to get a list of all of the NFTs in a particular user's wallet. Okay, so what this code is basically doing is it's going out and saying, well, what's the person's balance in their contract? How many tokens do they have? Now that we have the balance, let's loop over constantly and get all of the contracts that are available inside of each token, and then push those together into an array, and then store those. And then after that's all complete, then display those in the front end. So basically, this is kind of like a loop, right? It's a for loop. And this is good if you only have a couple NFTs in your wallet or a couple tokens. But if you have hundreds, this particular call could take 10, 20, 30 seconds, even a minute to load because it's having to loop through constantly and query the RPC provider, right? So this is not an ideal way to query data. We do that sometimes when we want to query like one thing we can use, or maybe a handful of things. But if we want to query lots of information, probably want to use something like the graph. And so this is where the graph comes in. The graph is basically a decentralized network that sits on top of all the blockchains. So you can think of it as this kind of additional layer, a middleware layer that just stores data. So we support over 70 blockchains, Ethereum, all the EVM compatible chains pretty much, Solana, Bitcoin, like there's all the major blockchains. We ingest that data, and we have these things called subgraphs, which are basically ways that people have collected and organized the data. There's over 200 indexers that are running and storing data for you. There's over 90,000 people that are delegating their stake, and there's over 600 curators. That's probably more actually now that are actually like providing some GRT tokens to the network to secure it. So the graph serves a large amount of queries, about 1 billion queries per day. And so the idea is to take this kind of like sea of a mess of transactions that are going on and organize stuff into little buckets. So you can imagine for every popular protocol, there's probably a subgraph for that. In other words, like if you want to query Uniswap data, there's a subgraph for that. If you want to query Aave, there's a subgraph for that. If you want to look at the foundation network for, AON Foundation for the NFTs, if you want to use Zora, if you want to use MakerDAO or whatever, any of these protocols, there's a subgraph that allows you to query that data without having to go directly to the blockchain. You can query the graph network. So what we can do is something like this, which is way cleaner, and it's called GraphQL. So if anyone does not recognize this, this is a GraphQL query. It's probably one of the most powerful parts of the graph because we call it the graph, but it's powered by a lot of things, which I'll get to, but most importantly, all the query layer is handled by GraphQL. So it's a query language that's very easy that allows you to specifically say, this is what I want to get. Give me back the response in one single HTTP response. No looping, none of that stuff. This basically translates to the exact same query we saw earlier, but we can just do it over GraphQL. Okay, so then we take that original idea of a dApp where we have a user interface like React, Next.js, and then we have our blockchain, which we still write to for security. Over here on the left, we still use the consensus algorithm. In our case, it's proof of stake, right? But when we want to read data from the blockchain, we don't have to go directly to the blockchain. Instead, the graph indexes all the data we care about inside of this little middleware layer, and then we expose that data over GraphQL to our interface, which is way more efficient and more performant. So I want to just briefly touch on the configuration. We're not going to get too much into the config because it's a little complicated. But the good thing is that there's a lot of tools that make it easier for you as a developer. And we'll talk about those in a little bit. But at a high level, a subgraph itself, or the name subgraph, basically means data API or configuration for your API. And so this is basically saying that, like, if you have a smart contract that you care about and you want to index the data and store it in a easy to query way, you need to write 3 config files to get that to successfully query and then publish those to the network. So this is comprised of a config file, which we call the manifest, which is like a high-level config file. It's a YAML file, so it keeps track of like what network that we care about, keeps track of what data sources and where to put those in the database. And then we have this entities file, which is like, again, it's referenced in the manifest that points to how the data should be stored in what formats, and what kind of like tables. You could kind of think of it like database tables. Your entities are like how you want to store the data. And then the WASM is actually the WebAssembly module. It's like a TypeScript-like code. It's called assembly script, and it is very similar to what we've been looking at with TypeScript, but it's a subset of TypeScript, so it doesn't have full support of TypeScript, but it has the same type safety support, and so it allows you to process data. So we high-level config are what we want, what we care about. We decide how we want to store the data inside of these entities in GraphQL and expose them. And then we process those using a WebAssembly module called a mapping. And so this is what takes the data and then actually processes it using a WASM, basically like a WASM runtime. Okay. So you can think of it like this. The blockchain emits events, or it might also query off-chain data, like in IPFS or Arweave, because we support those as well. And it will process those using WebAssembly, right? Inside of these, what we call handlers, which are very much like TypeScript. They're assembly script, and compiled down into a module and run constantly. So as these events come off, they get processed with WASM, and then they get stored in a database, right? Onside the indexers. So the indexers are running a database. And as people want to query that data, like the consumers, so this could be your front-end application, or it could be other people wanting to query the data that you've created inside of your subgraph, they use GraphQL. So they make a GraphQL request. The graph stack has this thing called graph node, which is like one of the binaries that runs on the indexers that decides like, okay, you want this particular data set. I know how to get it from SQL, so I will make the call for you. So you don't need to know SQL. It will get back the response and then serve the response over GraphQL. So you can think of it kind of like as, again, as a middleware. The graph is middleware. So this is kind of what the architecture looks like. So you can think of it very similar how we said before. You have a dApp, you have a front end on your dApp, your application, React, Next.js, whatever. It's your HTML, CSS, JavaScript, all the coding that queries your application. You still write transactions here to the smart contract, right? You still use the security of the network to proof of stake, and then submit your transactions. But as your smart contract emits events, Graph node, which is the machine, the workhorse here, picks up that data and processes it using a WebAssembly module, and then stores it inside of a database, right? So it processes it, stores it in a database, and then Graph node exposes all of that data over GraphQL using that very, very pretty GraphQL language that we can easily use to query the data. Okay. So I think I'll just take like a couple minutes to answer questions about this slide. The configuration is not too important, but it is kind of important that you at least understand the architecture of what is going on. Does anyone have questions? Let me check the chat too here. Let's see. How does Graph gain trust? So essentially, like, in order to be a participant in the network, if you want to be an indexer, so let's just say that I woke up one morning and was like, okay, I'm going to start indexing data for the graph. I have to stake GRT. So I have to stake 100,000 GRT just to become a participant in the network. Now I have to take that GRT, which that today is probably, I don't know, it's probably a few thousand, it's probably like $20,000 or something like that. And I have to stake it in the network. If I act maliciously and I serve data that's incorrect, I will get slashed. So that data will be served incorrectly. I will basically, people will alert on that because there will be a mismatch in the data and I will get slashed. It happens all the time. Well, not all the time, but it does happen sometimes. And so there's this kind of incentive layer of like you have to operate according to the rules and doing it properly. Um, okay, so I guess read is gasless. Yes, correct. Where and how do you store the data? So again, it's Postgres. So the data is stored in Postgres. The indexers run that, and they store the data inside of the database. So you don't need to know SQL. GraphNode handles all of the SQL queries. And so if you make a query to the Graph network, it will automatically find who has the data, and it will automatically serve that data using GraphQL. And I will definitely send the slides. So the
And
architecture is completely.
sorry, that was my question about storage of the data. And is it like stored in a decentralized or centralized way? That's kind of my question was. Sorry, I was not very specific. So
No,
you
no problem.
mentioned that
Yeah.
the indexers that are could be any people, basically any person. So
Mhm.
technically you could use my, I don't know, computer power, or what do you use for me if I become an indexer?
Yeah, good question. So no, the data, if you're an indexer, you're probably in the operation of like infrastructure. So you're not like building dApps. I mean, you might, but you're really just like storing data for other people. So that's one of the operators. So you're like setting up the stack. When someone creates a subgraph, they publish it to the network and say, hey, here's my subgraph. I'd like you to pick it up and store it. And all the indexers get to choose. It's like an opt-in method. So if I decide that, oh, Lucila just published a subgraph about her dApp, I'm going to go ahead and index it. She's provided a stake of like, I don't know, 2000 GRT. Then I can start indexing data and earn a reward for storing that data. So there's some tokenomics to it, but essentially I earn indexing rewards and I earn query rewards for storing her data. So the more people that use her subgraph, the more I get paid for storing it. So it's all opt-in. So the architecture is completely different from Web 2 APIs. Yes, this is all decentralized. There's no centralized kind of like operator storing the data and the API. The graph node are distributed. There's over 200 people running the stack at any given time. Yep. Did I answer your question about the network? Does that make sense?
What it will happen if all the indexers are gonna quit?
if all the indexers are going to quit.
Yeah, I
Uh,
mean, well, you will have no indexers, and then who is going to store the data for you? And
so a lot of the core devs run an indexer. So like Edge and Node runs one. Um,
yeah,
Pin X run one. Of course, there's always a chance that everyone stops running it. Sure, I don't know why they would, because then they'd stop getting tokens. So if it ever became like the token price was too low, maybe it wouldn't make sense for them to operate. I don't know. But yeah, of course, if everyone stopped running, then there would be no data. But I doubt that would happen.
makes sense. Thanks.
Yeah, no problem. Who supervises the graph node? So all of these are managed on their own. So we don't, no one supervises. We do code contributions to graph node. That's pretty much Edge and Node, which is the company I work for. But the network itself is all handled by individual indexers. They're incentivized to operate in a high availability and a high, what's the word? Basically they're incentivized. If they have a low response time or if they go down, then they're less likely to get traffic sent to them. So most of them are trying to operate at a yeah, high availability. Yeah, the graph is a little confusing, but I guess all you need to know is that we're going to walk through setting up a subgraph, which is basically just a way to index the data. And if you can understand that a DApp, a front end, you have your transactions that get proposed, which is, using the security of the network, and that smart contract is emitting events, and this is kind of like the write operations for the network. But when it comes to reading operations on the network, you don't really want to query your smart contract directly for large amounts of data or complex queries. And so really the concept is just like, yeah, deploying a subgraph, which is a unique way to store the data that's coming off of your smart contract in an easy to query way using GraphQL. It will make sense a little bit more as we go a little further. So let me stop this here. And then could I explain what WASM is? Sure. WASM is WebAssembly, which is basically like a way for you to, gosh, how do I try to explain how to explain it easy way? It's basically like a way to compile code down into a certain format called WebAssembly format, and run that. So there are different implementations of WebAssembly. The one that we use is assembly script, which is like a play on the name TypeScript. So it's assembly, it's compiled down into a very like low, secure kind of package, so that it can run in an environment like this, in GraphNode, where we're doing these like kind of data processing things, very, very small and transportable. And it's assembly script, so it's TypeScript based. And yeah, it's like a package. It's kind of like a bundled package. You literally compile it down into a runtime, and that's what gets executed on the network. I'm not going to go too much into that. You don't really need to know that. I'll kind of explain what the assembly script looks like, and just so you can see that. Okay, so let's